Okay, so one of the last things that we're going to talk about in this lesson is this idea of homeostasis. And so the first thing that I'd like to do, we're on page 14 here, is I'd like to help you achieve this learning goal, which is defining what the word means. And here's your answer right down here. Homeostasis is the ability of the body to maintain a stable internal environment. So what does that mean? That means that inside my body, I'm always going to be a specific temperature. I want to keep my body temperature within a certain range. I don't want it too high. I don't want it too low. I want it right in the middle. And your body's going to do this for a lot of different things. If you look at how much glucose or how much sugar is in your blood, your body again wants that right within a specific range. How much sodium, how much potassium, all of these different things, you want it within a very specific range. And this is what's really important, and this is our third theme, and if you're following along on our worksheets here, I'd ask you to write the third theme, and this is where you would write it, okay? But it's also found here in our lesson that homeostasis, keeping things constant inside, is absolutely vital to an organism's survival. If you cannot keep things within that range, that's where you start to see disease. That's whenever patients start coming to healthcare workers, is because their body has a malfunction of the ability to keep things constant on the inside. Okay, and so this is the second part of this theme, which is that there's this thing called feedback mechanisms, and we're going to go into detail. But those are the things that helps your body keep things constant inside. Okay, so let's go through this a little bit more. And you have some terms right here that are a part of your lesson, okay? And so I think I'm going to prefer to go through this from this PowerPoint slide here, because I think it will be a bit more helpful that way. Okay, so we're going to take the example of body temperature. That's the example that your book uses, but this applies to things beyond body temperature. Now you're going to see lots of graphs in the course this semester and next semester, so let's talk about how to read them. So first, this right here, this one that goes horizontally, this line, is called the x-axis. And right here is what it's telling you. It's time. So that means the further you go along here, the more time is passing by. Then the y-axis, which is the one that goes up and down, it tells you what it is. It's the body temperature. So as something goes up, that means body temperature is getting higher, and as it goes down, it's getting lower. Okay, so let's look at what this graph is telling us. So here, we're going to have this red line, and this is looking at the changes in, say, my body temperature as time goes on. And so you can see it starts here, goes down, then it goes back up, and then it goes back down, and then back up. The important thing is that if I'm having normal homeostasis, a normal internal environment, there's an ideal average value. That's your set point, okay? So what that means is say, for body temperature, 98.6, okay? That's our ideal right here. That's the set point. It's right in the middle. But you can see that my body temperature is going to fluctuate. It's going to be a little bit above that average, a little bit below, but it's all within normal. The normal range is going to be values above and below the set point that are considered normal, that are within homeostasis. Okay, and so if you're following along on your notes sheet, there's a place here for you to find these things. So for set point, you could say an ideal average value. Okay, and we might add in here the normal range, and the normal range are going to be values above and below the set point that are normal. Okay, so you're still within homeostasis. Okay, so let's go back here and see how does the body keep things within this normal range. Okay, what's going on? And again, we're going to still use this idea of temperature, and this information is also found in your book. Okay, so homeostasis, normal body temperature, it's in that normal range. Okay, now the first thing we're going to have is a stimulus. This means something has changed. Okay, and so say for example, it's summertime as I'm recording this right now. So say for example, I decide to go out and mow my lawn in the middle of the day in 100+ degree weather. Okay, the stimulus would be the hot outside environment. And that hotness is hitting my body, and it's starting to heat up my body. My body is getting hot. So there are going to be things that sense the fact that my body is getting hot. Okay? And there's two places. There's temperature sensors in the skin and in the hypothalamus. Hypothalamus is a part of your brain. Okay, so receptors are things that sense the stimulus. And so you felt that before. If you're outside, your skin actually starts to feel a bit hot. Have you ever felt the sun almost burning your skin because it was so hot? Okay, so those are those temperature sensors in the skin. And what they do is they send a message to what's called the control center. And this would be the part of your brain. It's called excuse me. It's called thermoregulatory. Again, this is a word we can break down. Thermo, you can think of thermo, it's in the word thermometer, it's in the word thermos, it has to do with temperature. So the temperature regulatory, it's regulating temperature. It's the part of the brain that regulates temperature. So receptors tell that part of the brain that regulates temperature, hey, Dr. Pendleton, it's really hot out here. Okay? And so this is the sensation. You get a stimulus and your body is sensing that change. So what does your body do? Well, it sends a message to things called effectors. Effectors are the things that do something about it. They have an effect. Okay? A lot of times I think you may know that one person, or maybe you are that one person, who they're going to get stuff done. And that's what the effectors are. Okay? And in this case, there's two effectors, main effectors, when you're too hot. Sweat glands, and then also blood vessels. Okay? And sweat glands are going to sweat, and blood vessels, it turns out your body carries heat in your blood. And so if the blood vessels dilate, that means that the diameter of that blood vessel gets bigger, and that makes the blood go closer up to the skin, and you start letting heat out through your skin. Okay. And as you sweat, as you get rid of some of that heat that you carry around in your blood, you have a response, which is that your body temperature that was getting too high starts to go down back into that normal range. Okay, so let me recap. Normal body temperature. I decide for whatever reason I'm going to go out and mow my lawn in 100-degree weather in the middle of the day with no shade. It's a stimulus because it starts heating up my body. And receptors in my skin and in part of my brain sense this, and they say, hey, Dr. Pendleton, it's getting hot out here. You're starting to heat up. They send that information about temperature to the part of my brain, the control center, that can basically say, hey, it is too hot, let's go do something about it. And this center, this control center, sends a signal to the effectors, the things that get things done. And those effectors are sweat glands, blood vessels, sweat glands sweat, blood vessels dilate, and that causes your body temperature to go back down, which is the response. Okay, so let's look at that here. That would be a situation where here I'm going out, I'm getting hotter, 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 and this is the point where my body starts to say, hey, it's getting too hot, we've got to respond. And so here I might start sweating, I might start having those blood vessels dilate, and that brings my temperature back down. Now what happens on the bottom side? Well, have you ever been so cold that all of a sudden you start shivering? Okay, well, that would be different effectors. Okay, so it's going to be still some of the same receptors. It's not always the same receptors, but in this case, some of the same receptors are going to sense that. They're going to send a signal to that control center. It sends a message to the effectors, which in this case are your skeletal muscles, and they just start contracting, so you shiver, and that's going to bring this temperature back up. Okay, so we now need to talk about this is what feedback is. That's called feedback. Okay, we sent something and then we responded. Now there's two types of feedback: positive feedback and negative feedback. Okay, now this is my trick that I tell my students for how to remember the difference between them. Okay, so let's again take our body temperature example. Our body temperature starts to rise. So I will take one finger, and you can do this in your exam, and say this is the direction things are going. It's rising. And the response right here is to bring it back down. So the response goes the other way. And I ask myself, are my fingers pointed in opposite directions? If the answer is yes, it is negative feedback. Let's do it down here. My body temperature is starting to drop. So that's the stimulus, body temperature going down. And then the response brings that body temperature back up. Are my fingers going in opposite directions? Yes. So therefore, what type of feedback is it? Negative. Okay. Most types of feedback in the body are going to be negative. Now, a lot of times we think of the word negative to mean something that is not good. That's not what it means here. All it means is that stimulus and response are in opposite directions. That's all it means. It's actually good for your body. If you didn't sweat, your body temperature would get too high and you could potentially die. Okay. Now, positive feedback. Positive feedback, and a good example of this is going to be labor contractions, is that you have something that starts, contraction of the uterus. And what happens is your body keeps making those contractions more and more and stronger and faster until what happens? Until the baby comes out. Okay? So that's positive feedback. Stimulus is start of the contractions, and response is let's make this change more until baby comes out, and now the body's back to normal and where it needs to be. Another good example is blood clotting. So that would be, say, you cut yourself. Okay? So I've cut myself, and I've got a hole, I've got a gap in my body. I need to plug it up. Well, clotting means that you start to form the beginnings of a little scab. And so you start to form a clot, you form it more, until you plug up the hole and blood can't leak out of your body. Okay? So again, negative stimulus response, positive stimulus response. Okay? All right. Let me see if there's anything else that I need to add in here. I would just make sure you go through this and think about, given what we've just talked about, how would you define in your own words what each of these things are? And as a reminder, here in the lesson, it gives you my wording, but I would see if you could also put that in your own words to make sure that you really understand.